And by now you should understand how to do a simple start-stop control station. And I've got two of these shown here to control two different motors, motor 1 and motor 2. And we have our control system set up here on the right and the motors on the left. Each one of them, you have line 1, line 2, line 3 going to motor 1, and line 1, line 2, and line 3 going to motor 2. Independent set of contacts controlling motor 1 and an independent set of contacts controlling motor 2. So we have a set of rungs here. You can see on 6 and 7 that control motor number 1, and on 8 and 9 that control motor number 2. For now you could ignore these contacts on rung 10. They're just there for me to store for use at a later time as we get going in this lecture here. So if I hit start 1, motor 1 is going to energize. Whoop, I got to turn power on first. So let's turn power on. Here we go. Everything is all powered up. Now if I hit start 1, motor 1 is running. You see the holding contacts have closed to maintain power to the M1 coil. And if I push stop, it'll open the power flow to M1 and shut everything down. Hit start again. And if I open the overload, again, power flow through M1 coil is interrupted, and that stops and opens up everything. Reset the overloads. Now, motor number 2, same thing. Hit the start 2, motor number 2 is running. Hit stop 2. Interrupts current flow, de-energizes the M2 coil, these contacts open up, and motor 2 stops. Again, let's try that again. We're running, overload opens, interrupts current flow, everything shuts down. Okay? Very simple. You've got motor 1 running, stop it. Motor 2 running, stop it. Now in this particular case, we can have both motors running at the same time. Nothing wrong with that. They're both going, both operational, no problem. But what if you have a situation where you only want one motor running at a time? Motor 1 or motor number 2. If motor 1 is running, you don't want to be able to start motor 2. And if motor 2 is running, you don't want to be able to start motor number 1. Well, we can solve that by putting a set of electrical interlocks in our control line. So I'm going to go here, turn off the power, and I'm going to come along here. I'm going to delete that. I'm going to move a set of M2 contacts up there to M1, and a set of M1 normally closed contacts up there in series with M2. Now, if I look at this, I have these contacts now in series. Okay? They're in series with our M1 coil, which means if they open, it'll prevent power flow through the M1 coil, and if they're already energized, it'll drop them out. If this coil is energized, it'll drop out these contacts here and the motor will stop. Now, let's go ahead and start motor 1. And you see the contacts from M2 were closed because it was not running, so it allowed us to start and energize the M1 coil, and motor 1 is over here running. We can see that. Now, if you look down on rung 8, you will see that the M1 contacts, the normally closed contacts, are now open because the M1 coil is energized. That will prevent M2 from ever starting. I can keep pushing the start button, nothing happens. See that? Push the start button, start 2, and nothing happens. M2 or motor 2 is prevented from running when motor 1 is running. So let's go ahead and stop. It's running. Okay, we'll start motor number 2. Now motor 2 is running, and you look up and you can see the M2 contacts are open, which will prevent us from starting motor number 1. That's pretty good. Now we've got an addition of simple, normally closed interlock contacts. We can have motor 1 or motor 2 running. All right. Now, let's say we want to go and put some other additional protection in here. Let's go say we want to put a limit switch in. So let's drop that off and drop that off. And I'm going to go and take this limit switch and that limit switch. Oh, I got to move it. There we go. We'll go back. Fire this up. And here we go. Now we hit our start. Motor 1 is running. You see we can't run motor 2. And we trip the limit switch. It's labeled FLS. Shuts it down. It's all off and everything. Alright. Now reset that limit switch and we can start it again. Trip the limit switch. Reset it. And that's fine. Same thing with motor number 2. Run it. Trip the limit switch. Stops it. There. Now, what we have are 2 start-stop stations. Very simple. What if I want to make this a forward and reverse control? You have all the components you need right now. We do a little bit of rewiring, and we have to take care of some wiring on the motor. Since it's a 3-phase motor, we're going to go ahead and change the wiring on the motors. And we will eliminate one of the motors. But first, let's do our control system. Okay? I'm going to move, stop one over. And then I'm going to take stop 2 and put it right up there. And then check this out. Simple connection of the 2 sets of controls. So if I push either stop, whichever motor is running will stop. Either stop, whichever motor is running will stop. Okay? So now let's go back here. And I'm going to come in here. I'm going to, instead of this, start one. I'm going to label that forward. And instead of start 2, I'm going to label this one reverse. Okay, I'm not going to relabel all the coils and the contacts right now because you can see that carry over. So let's come on over here and whoops, got to turn the power on. There we go. Now hit the forward button. Okay, in this case the forward motor is running. Hit either stop and it'll stop. Hit the reverse button, and now in this case the reverse button is running. So now we're all set up. We are set up to get into here and go into reversing motors and everything. Alright, now in this case up on the primary, not on the primary, but on the incoming side to our starter, I have a line 1, line 2, line 3, line 1, line 2, line 3. Now, remember your 3-phase motor theory. In order to reverse the direction of a 3-phase motor, we swap any 2 leads. And you can do that either on the top of the contactor or the bottom of the contactor. In your lab, I have you doing the swap on the top. Line 1 goes to line 3. Line 3 goes to line 1. Line 2 stays to line 2. Here, we'll do the swap down here on the bottom. So I'm going to take this off, and I'm going to delete the second motor. Okay. Now, line 1 is going to go to line 3. Here we go. Whoops. Here we go. And I'm going to delete. I've got to delete the wires. Okay. Line 2 is going to go to line 2 again. Whoops. I keep getting clicked in the wrong area. Here we go. Down here. Line 2. It's going to go to line 2, remove the short. And then finally line 3. We're going to have to move the motor down for this. Okay. There we go. Get this all. There we go. And finally line 3 will connect up to line 1. Keep on going. Keep on going. Remove the short. Remove the short. The connection. I should say remove the connection, which then removes the short. So there we go. And you can see here on the back side, you've got your line 1 connecting to line 3. Line 2 connecting to line 2. Line 3 connecting to line 1. So we're swapping line 1 and line 3. So we'll change the direction of the motor. Now we can come back on up here, hit run, close the disconnect, everything's going. We hit the forward button, and you can see the forward direction starter has energized and the motor is running in the forward direction. Okay? Come over here, reverse, and nothing happens. Alright, which is a good thing, because then we would be creating a short circuit here if both contactors were on at the same time. Go ahead and hit stop. Now we can hit reverse. Alright, now in this case it's going through the reverse starter and coming back and energizing and running the motor. Now there's one more change here we have to make, and that's with the overloads. There are occasions where you would have separate overloads and separate circuits. If the motor were to overload in the forward direction and you absolutely had to back it up for some reason, there's potential to run it separate overloads like this. But typically if the motor overloads, the motor stops due to an overload condition, you want to protect the motor and not allow it to run at all. So we're going to come up here, delete this, and delete this, and come up over here, bring this there, and now connect them both up. Right. Now this is your typical forward reverse starter controls that you'll find. And what we have now, let's go back and turn the power on and run this. Okay, here we go. And I'm going to scroll up just a little bit. There we go. We can barely see the motor there. See if I can get some more room there. Okay, the motor's there. Run our forward. Alright, and the forward overload opens up. Alright, and while that forward overload is open up before it has a chance to reset, see, we can't start the motor in the reverse direction, and we can't start it in the forward direction. It cools down, we reset it, now we can start it in the reverse direction, and it's going reverse. Again, if it overloads in the reverse direction, this overload will open overload 2, and we won't be able to start that until the overload condition is reset. Okay? that will take care of the operation of this circuit. Now your circuit is very similar that you have for the lab that you'll be building. There are some differences. For one thing, well, I'll talk about the circuit differences as soon as I bring it back up here. Okay. All right. In our lab, a few things here. Okay, you notice that the overloads are not in series at this point. And that was done on purpose on this lab. And in the example I just showed, we had our overloads in parallel. In series. Here we have individual overloads. And I have that done on purpose, and it's for demonstration purposes later on and for testing purposes, to test to make sure that you properly wired things. Okay, now we look over here, you see our limit switch, our interlocking contacts, and then again our overloads. Down here we have a couple of indicators. We have a forward on indicator that's using the auxiliary contacts, and we have a reverse on indicator using auxiliary contacts on your controller. Now, one of the things in your single phase set that we've got put together here for this, since you're having to do the work at home due to COVID and everything, we do not have a three-phase source. All right? And you'll be using the CR1 socket. Okay, you're using the CR1 socket to go and simulate the three-phase input to the starters. And you'll have pictures of that, and we'll show you that, everything, where those come from. So the CR1 socket will simulate your three-phase source, and you'll wire up the input to your starters. In this case, I'm asking you to line 1, 2, and 3 to the forward, and then line 3, 2, 1 to the reverse. On the back side of the starter, line 1 goes to line 1, line 2, T1 goes to T1, T2 goes to T2, and T3 goes to T3. Then you take it out to a set of terminals that will simulate your motor connection. Again, we don't have three-phase here at this take-home kit, so we're going to simulate the connection to the motor, and then the actual operation will be shown by either the forward on light or the reverse on light operating. Okay. Operation of this, pretty much the same. Okay. We come in here, and you push forward. Forward light on, motor's running, you see the forward contacts are closed, so the motor's running in the forward direction. It stopped. Now you hit the reverse. Looks like I need to label that button. And motor is now running in the reverse direction. And the reverse light is on. Okay, while I'm thinking of it, I'm going to go label that right away. Okay, that's pretty much it. As you can see, what we started with were two start-stop control stations. We added interlocks in there to prevent one coil only operating at a time. Now in your case, you also have a set of mechanical interlocks, but it's just my own personal preference, even if you have mechanical interlocks, to wire in electrical interlocks. Mechanical interlocks have been known to come loose, have breakages, and it's another point of failure. And with these IEC contactors we're using, it is fairly simple for someone actually to put this together and not have the mechanical interlocks in there, so it's always safe. I always wire a reversing starter with the electrical interlocks in place. And you can see the normally closed reverse contacts are in the forward rung, and the normally closed forward contacts are in the reverse rung. That's pretty much it. It's pretty straightforward. Amazing how many people, as soon as we start putting stop buttons in series and overloads in series, they lose connection as to what's happening. And you can see that if you break this down, this is just a simple start-stop station that's been combined into one operation.